Welcome to the DIY Honda Garage channel. DTC P0101 corresponds to a MAF Sensor Circuit Range performance problem, specifically affecting the mass airflow MAF sensor. This sensor plays a crucial role in measuring the amount of air entering the engine. The Engine Control Module, ECM, uses this information to adjust fuel injection and optimize the air-fuel mixture for efficient combustion. Located typically near the air intake duct, the MAF sensor works in conjunction with the intake air temperature IAT sensor. It's vital for the vehicle's performance, as any issue can lead to engine misfires or reduced fuel efficiency. Therefore, accurately diagnosing this DTC is essential for maintaining optimal engine performance and preventing further complications. The DTC P0101, indicating a MAF Sensor Circuit Range performance problem, signifies that the MAF sensor is not functioning within its specified range. This could mean it's reporting either too low or too high voltage readings. The MAF sensor is essential for the engine's fuel management system. It measures the volume of air entering the engine and helps determine the proper air-to-fuel ratio. Positioned typically downstream of the air filter, it receives air directly from the intake manifold. Contained within its own enclosure, its accurate functioning is paramount for engine performance and fuel economy. Additionally, the IAT sensor, which is typically located within the same housing, also assists in providing air temperature data, further influencing fuel delivery and engine timing. Several potential causes may lead to the P0101 DTC. A faulty MAF sensor itself is a primary suspect, as these sensors are sensitive components that can fail over time due to dirt, moisture, or wear. Damaged wiring harnesses can also lead to incorrect signals being sent to the Engine Control Module, ECM. Additionally, electrical connection issues, such as poor contacts or corrosion at the connectors, may result in unreliable readings. In some instances, the issue may even stem from a problem in the Powertrain Control Module, PCM, which interprets the signals from the MAF sensor. Thorough examination of each of these potential causes is crucial for effective troubleshooting. Drivers may experience various symptoms if the DTC P0101 is triggered. One of the most noticeable symptoms is reduced engine performance, characterized by sluggish acceleration and hesitation during driving. Additionally, poor fuel economy could arise due to inefficient air-fuel mixture calculations, leading to excessive fuel consumption. Furthermore, the illuminated check engine light on the dashboard serves as a direct indication that something is amiss within the engine management system. In extreme cases, the vehicle may enter a limp mode to prevent potential damage to the engine, which may further exacerbate these symptoms, leading to a frustrating driving experience. In the first troubleshooting step for DTC P0101, begin by turning the vehicle's ignition to the on position. It's important to wait approximately 2 seconds to allow the vehicle's diagnostic system to initialize. Next, using the Honda Diagnostic System, HDS, check the MAF sensor outputs. Specifically, look at the signal values being reported and compare them against the specified threshold of less than 0.59 volts. Evaluating these parameters is essential. If they align, this indicates that the failure can be reliably reproduced, allowing you to proceed to the next troubleshooting step. If they do not match, move to an alternate set of checks to identify intermittent issues that may not always manifest during the initial test. In the second troubleshooting step, you will again examine the MAF sensor values with the HDS. This time, you are looking for signals exceeding the threshold of 4.89 volts. If the value indicates higher than expected output, it suggests a possible failure in the sensor or the related circuitry. If you find an intermittent issue, it's critical to check for poor electrical connections or loose terminals, particularly at the MAF sensor, IAT sensor, and the PCM. Documenting any snapshots of the DTC captured by the onboard diagnostics can be beneficial, as it provides a frame of reference for similar driving conditions where the failures occurred. If the sensor values are stable and meet expectations, further examination of the circuits and connections will be necessary. The third step involves ensuring the vehicle is turned off before proceeding. Disconnect the MAF sensor/IAT sensor 5P connector from its harness. This disconnection is vital as it allows for accurate measurements without interference from other systems. Afterward, turn the vehicle to the on mode to measure the voltage between test points defined in the diagnostic guide. Specifically, you will want to monitor the voltage between the female terminal number 3 of the MAF connector and the body ground. Confirming battery voltage during this check indicates that the associated wiring, particularly the IG1 ACG, IG1 main, and IG1 AFM lines, is functioning correctly. If battery voltage is absent, it signals an open circuit that needs to be repaired, ensuring electrical continuity to restore functionality. For the fourth troubleshooting step, you will again turn the vehicle off to prevent any electrical shorts while you conduct your measurements. Make sure the MAF sensor or IAT sensor 5P connector is still disconnected. After this, measure the resistance between the appropriate test points, specifically between female terminal number 5 of the MAF sensor connector and the body ground. You'll aim for resistance values of around 170 to 210 kiloohms. Achieving these resistance specifications confirms that the circuit is intact and functioning properly. If resistance differs significantly, it suggests potential issues within the vehicle ground or sensor line, which would then necessitate further inspection to locate the fault. In the fifth step, you must jump the SCS service connector switch line using the HDS and allow it to sit for more than 1 minute. This allows the diagnostic systems to reset and accurately capture new measurements. After this, disconnect the PCM connector B51P. With both the MAF sensor/IAT and PCM connectors disconnected, check for continuity between female terminal number 5 of the MAF sensor connector and the body ground. Continuity indicates that the VGP, vehicle ground positive wire between the PCM and MAF sensor is intact. A lack of continuity would indicate that shorts or breaks exist within the wiring system, which would need to be repaired to restore proper function. In this sixth troubleshooting step, continue examining for continuity between the specified test points. With the vehicle in the off/lock mode and both the MAF sensor IAT and PCM connectors disconnected, measure for continuity between female terminal number 5 of the MAF connector and terminal number 32 of the PCM connector B51P. A successful continuity test indicates that the VGP wire is functioning correctly, allowing signals to be transmitted efficiently. If continuity is absent, there is a fault present in the VGP wire between the PCM and the MAF sensor, requiring careful tracing and repair of the wire to rectify the issue. The seventh troubleshooting step focuses on validating the MAF sensor's functionality. Begin by substituting it with a known good MAF sensor/IAT sensor to rule out component failure. After performing the substitution, ensure all connectors are securely reconnected to their respective terminals. Now, turn the vehicle to the on mode and clear any diagnostic trouble codes present using the HDS. After clearing the codes, start the engine and maintain a constant speed of 2,000 RPM in either park or neutral. During this time, Check again for pending or confirmed DTCs. If DTC P0111 reappears, it points to further issues, either within the sensor circuit or the PCM itself. However, if no codes are indicated, the sensor was likely the primary problem. In Step 8, your focus shifts toward the VGN, Vehicle Ground Mesh Wire. With the ignition in the off position, jump the SCS line in the same manner as previous steps. After allowing time for the diagnostic system to reset, disconnect the MAF sensor IAT connector and the PCM connector B, 51P. Measure for continuity between female terminal number 4 of the MAF connector and terminal number 33 of the PCM connector. Establishing continuity suggests that the VGM wire is functioning properly. If the continuity fails the test, it indicates an open circuit within the wire, which will need to be located and repaired to ensure proper electrical path. During the final step of the troubleshooting process for DTC P0101, reconnect the PCM connector B, 51P, to the PCM. After ensuring proper connection, you must then establish a bridge using a jumper wire between terminals A and B of the MAF connector. With these connections in place, turn the vehicle's ignition to the on position and clear any existing DTCs. After clearing, monitor for pending or confirmed DTCs once more with the HDS. If DTC P0101 reappears, consult authorized service information to locate further guidance specific to the symptoms being experienced. Should no DTC be indicated, this suggests that the internal circuit of the PCM is functional, and it is advisable to proceed with replacing the original MAF sensor/IAT sensor if other checks have been completed. Upon completing all necessary repairs associated with DTC P0101, it is vital to perform a final verification process. First, ensure that all the requisite repairs and components have been addressed thoroughly. Once confirmed, check for any stored or active DTCs by utilizing HDS to ascertain vehicle status. After clearing any existing codes, a test drive is necessary to validate the repair's success by assessing the vehicle under normal driving conditions, monitoring for engine performance, and ensuring that no warning lights illuminate will ascertain that the issue has been resolved. If issues re-emerge during the test drive or additional codes appear, further analysis will be required based on the new findings. Preventive maintenance is essential for sustaining the performance of the MAF and IAT sensors. Regularly cleaning the MAF sensor can help prevent dirt and debris buildup, which could impede its sensitivity and accuracy over time. Additionally, it is advisable to routinely inspect wiring connections for signs of wear, corrosion, or loose terminals, which can contribute to sensor issues. When replacements are necessary, using original equipment manufacturer (OEM) parts is highly recommended to ensure compatibility and reliability. Conducting these maintenance activities will help to minimize the likelihood of DTC P0101 or similar codes appearing in the future, thereby enhancing overall vehicle dependability. In conclusion, the DTC P0111 signifies a problem with the MAF sensor circuit and its ability to deliver accurate readings. The MAF sensor plays a critical role in optimizing engine performance, as it directly influences the air-fuel mixture for combustion. A meticulous sequence of troubleshooting steps helps to isolate the problem, ensuring a systematic approach to either repair or replace faulty components. Following best practices in both diagnostics and preventive maintenance can significantly reduce the chances of encountering this DTC in the future. By maintaining the MAF sensor and its associated wiring, vehicle owners can ensure prolonged engine performance and reliability. Please like and subscribe to the channel. See you next time.